So we're starting from where we left off last time. So we have our vehicle in here already. We have our track in here already that we're going to use. And we have our results from just the regular simulation. So you can see below, we created a table and a couple charts last time, as well as a track map. I'm going to go ahead and get rid of these just to make sure they don't confuse anybody or have more options than we need. And we're going to start over here in the simulation tab. So last time we used just regular simulate all. We're going to run a batch run so that we can sweep a parameter this time. So we're going to select batch run, and we're going to, it should pop up just like this with a single parameter selected. We're going to go for something easy to understand that we know, so we'll pick vehicle mass. So to get a larger effect here, obviously more wild than you would regularly see, I'm going to make these numbers a bit larger as far as the disparity between them. So it's very easy for us to see. So there is a limit on number of steps and a couple other things here. Play around with it. It tends to be right above 20, but depends on how detailed you want to look at it. And keep in mind, it is a point mass. So we'll go ahead and click run. And so since this was a sweep now, it's given us our various, options that it ran for it, and then a lap time equivalent to that mass. Obviously here it's a little hard to read this axis, and you can go in and modify this, or if you truly wanted, details from this, go ahead and export that CSV, open it up in Excel, and make the graph to the parameters, that you desire. But for this, it's easy to understand the relationship between vehicle mass and lap time. So it's clear what it's showing us here that, the lighter a vehicle, if we go down to the 200 kilo one, has a significantly faster lap time, than the 2 seconds extra if you had another 100 kilos added on. So, things like this give you a good ballpark estimation of what things would look like, what parameters would change here. There's not a whole lot you can do with these batch charts, right? Because you're only modifying a single variable at a time. You don't get as many options of how you can manipulate the data as you do if you run a single car on a single track. So now that we have this guy, there's it's going to appear in 2D batch files. We're going to go ahead and hide it. We're going to go ahead and close it. And we're going to get a bit more complicated with it. So let's say we want to compare not just vehicle mass versus lap time, but if we wanted to compare two variables that we know have a relationship to each other. So a real easy one to understand, I guess easy, depends on how long you've been around it, but one that's easy to show and you can predict the result is drag coefficient. And then if we enable a second parameter, we'll do downforce coefficient. So same thing as before, I'm going to create some wildly different numbers here. That way we get a large change in lap time. So it's very easy to see and make our point. There is a lot worth mentioning right here, right? So it shows you the value the car has preset. That's normally a pretty good estimation of what we're going to see and what we're going to run. So running something like this, you need good justification between what your minimum and what your maximum are, because this is a wild range. If you're actually designing a package, you wouldn't have such a large area of scope you're looking into. And then the second thing to keep in mind here is number of steps. If I put 20 here and 20 here, that's going to be a lot of iterations it's going to run, and the program's very likely to crash. It will do it, just be aware it might take you a couple tries. So if you're trying to just get a couple relationships down on paper, make sure it matches what you've read, what equations you have, and what ideology you're going with. Doing something like 10 steps or 5 steps is plenty. So we'll go ahead and run this, and it's going to run a couple batches worth, and then we're going to get a nice chart. So this is a 3D graph. Once again, if you want to interpret it in a different way, export the CSV, bring it into Excel, show the data against the data you really want to see. But from this, it's easy to see as our drag coefficient goes up, so does our lap times. As our downforce coefficient goes down, our lap times go up, which is exactly as we would expect it. But, this is a great use of this tool to show, okay, if I increase my drag by this amount, how much downforce do I have to increase for it to be worth it? And once again, you got to keep in mind this is in a point mass simulation, so there's absolutely limitations to it. I would not put an incredible amount of stock in the graph as they give it to you. I would definitely drop this, into a CSV. I'd, grab our whole chart for it, put it out here. We'll label it test two, and I'd graph that out, which is definitely something I want to show in these as well. But we'll go ahead and pull that up just so we can all get a good idea of what that CSV is going to look like. So you can see in test two, you get a very different format from what you got in the previous one. And it's going to show you just the line of results from each simulation that it ran here, right? And you're definitely going to have to get in here and label these as you want, get your axes as you want. There's going to be a lot of data that you aren't going to use, aren't going to need, but it's all here for you, and you can put it into a much cleaner lap time or a much cleaner graph of that. Right, and that should be it for doing batch simulations. And this is about the limit of what we use the software for. Once again, there's a lot of good things you can look at with it. There's a lot of things that should best be left for other types of analysis. But if you can accompany something with point mass, you definitely should.